Okay, welcome back to another IGCSE lesson on atoms, elements, and compounds. This is part 2. We'll be looking at ionic compounds, ions, part 3 and 4 of the syllabus. Core 3, describe the formation of ionic compounds between elements in group 1 and group 7, including the use of dot and cross diagrams. We'll also be describing the properties of ionic compounds, high melting points and boiling points they have, in general, good electrical when aqueous or molten, and poor when solid. We'll go into more details what we mean by poor conductivity and why. I pose this question: can we draw an ionic compound using the dot and cross method? Yes, of course. What is the dot and cross method of representing substances in terms of showing us in terms of bonding? Can you describe the chemical and physical properties of an ionic compound? For example, an ionic compound has or is. Now we're going to look at bonds in more detail. Ionic bonds occur, as we know, recap between metals in general and non-metals, usually those metals that are the furthest to the left-hand side of the periodic table, group 1 and group 2, and with the non-metals tend to be group 6 and group 7, have the strongest chances of forming ionic bond. Here we've got an example here. We've got lithium. Just going to point it out here with a bit of pen. I think I'll use blue this time. So we've got lithium Li with fluorine, the halogen. So that's a group 1 metal. So that's group 1. And this is group 7 Roman numerals. And they've got a high probability of forming an ionic compound. So you've got here group 1 and group 7, ionic, group 1 and group 7, potassium chloride, ionic also. Okay, so we're going to have a closer look at formation of ions, show you a few different methods and notations. So ions are formed involving charges. We've got a positive charge, in this case group 1 metal, where it loses 1 electron from its outer shell to form a positive ion, and then we've got halogens, which is a group 7 non-metal, and it gains 1 electron to obey the octet rule. 7 plus 1 is 8, forming a negative ion of -1. So ionic bonds are usually, most of the time generally, very strong electrostatic attraction between oppositely charged ions. We're going to have a look at an example here between lithium and a fluoride ion. So you can see here that lithium has formed a +1 charge there. I'll just draw it red. And fluoride is -1. We've already gone through that in previous slides. If you don't know how to do that, please feel free to look back through my videos. And then it forms a strong charge between the two here, called an ionic bond. Bond between the electrostatic attraction between the oppositely charged ions of fluorine and lithium. Now we're going to show a few different ways that we can show this bonding occurring between oppositely charged ions. Here's one example here. I'll just bring out my little blue pen marker here. Here we've got lithium atom and the fluorine atom. We're showing the shells here as indicated by the little curvy bits. So the shells here and here. And this little squiggly arrow there is just showing you what happens when a lithium ion, being a metal, gets close to a non-metal fluorine ion. It tends to want to be lost. And the next slide will show you what happens. So we form a lithium ion with a charge of 1+, and that little electron is joined up to here to give us 8 electrons, but a charge of 1-. And then we get this electrostatic attraction here, which is the ionic bond. So that's the electrostatic attraction between oppositely charged ions. I'm just going to shorthand that there. Another way of representing this is the dot and cross form, but before I say that, I've just squared up the name lithium fluoride. I'll just point out to you that non-metal always ends in IDE in general. You notice the metal isn't called lithide, it's called lithium. But the non-metal changes from fluorine to fluoride. So here's the notation showing the shorthand version, and I'm showing the shells underneath 2127. and then you can see the shell, it's full because it lost electron. 2, you can see the shell's full because it gained electron in the outer shell, where it went from 7 to 8, and this went from 1 to 2 because it was lost. Now we look at the dot and cross form, and they just show you the electrons in the outer shell. So we're just looking at this number here, I'll just squiggle there, the 1 and the 7 on lithium, and then the 2, which is no shell on the outside here because it's been lost, but we've got 8 electrons here. So we're showing it all this. Okay, so the lithium ion here, we've got 1 electron, we've got 7 here for fluorine because it's a group 7, and then that 1 gets shared and slots into that little position there, and then this is the complete dot and cross showing you the full outer shell. Next part showing you number example. See if we can reaffirm and confirm your understanding. So that we've got potassium and chlorine together forming a potassium chloride ion. Here it is in terms of shells, and we've also got the nucleus here showing you the number of protons and electrons. Potassium is a group 1 metal, it loses 1 electron to the chlorine, which has only got 7, so by losing 1 from the potassium it gets a full shell complement of 288, which forms a stable ion, and then this electron gets attracted to or lost to chlorine, it gets a stable shell. This 7 here, according to the octet rule, will go to 8. Here's the next slide. So we formed again a positive 1 for group 1 metals and a negative 1 for group 7. Notice the name is called potassium chloride. Remember, the non-metal always ends in IDE in this case. Next slide. Okay, example 2, showing you the dot and cross. Here's the shorthand example here of potassium. You look that up on your periodic table. It's 19, so it's 2881. There's the outer shell. Chlorine's 287. There's the outer shell. And there's the subsequent coil shells when the electrons are lost and gained. So that gets lost there. And then chlorine gains, so lost 1 electron. And then chlorine gains 1 electron. Here we've got the charges 288, 288. What's it look like as a dot and cross? You've got potassium, it's got 1 electron designated by the blue dot, and chlorine's got 7 electrons designated by the 7 red crosses. When it forms a stable ionic bond called potassium chloride, this is where all the electrons are received and shown.